The US military just pulled the trigger on a whole new combat caliber, and it's not what everyone's been arguing about. Forget the endless debates over 5.56 by 45 NATO versus 300 Blackout. The Army has officially adopted the 6.8 by 51 mm Common Cartridge, known in the civilian world as the 277 SIG Fury. This is not a boutique wildcat or a minor tweak. It's a ground-up reinvention of infantry firepower. Over the next few minutes, we'll explore how decades of battlefield feedback led to this decision, dive into the engineering marvels that make it possible, see the difference it makes for soldiers under fire, and even examine why hunters and precision rifle enthusiasts are already clamoring for it. By the end, you'll understand why Overmatch has become the guiding doctrine, why this round shatters the limitations of legacy cartridges, and what it means for the future of small arms. Strap in, incremental upgrades are over. The era of decisive one-shot stop performance at distance has arrived. For more than half a century, the 5.56 by 45 NATO cartridge defined infantry engagements for the US military. Developed in the late 1950s and fielded in Vietnam, it offered a revolutionary combination of high muzzle velocity, low recoil, and lightweight. Soldiers could carry hundreds of rounds, deliver high volumes of fire in close quarters, and manage follow-up shots without throwing their aim off. Against unarmored opponents and within 300 meters, it excelled. But the nature of warfare has changed dramatically. Modern battlefields feature near-peer adversaries equipped with advanced plate carriers rated level 3 and 4. These steel-ceramic polymer composites can stop or deflect multiple hits from 5.56 by 45, especially at anything beyond point-blank ranges. During recent deployments, after-action reports painted a stark picture. American infantry found their rounds bouncing off armor plates unless hit placement was near perfect, requiring multiple hits to neutralize a target. Meanwhile, enemy shooters armed with longer-range rifles could accurately engage US troops from standoff distances, denying maneuverability and amplifying the threat. Even expert marksmen experienced the same terminal ballistic shortfall. This wasn't a training issue, but a fundamental limitation of the cartridge. The doctrine of spray and pray, relying on volume of fire to compensate for individual rounds' lack of stopping power, began to look like an outdated relic. In its place emerged the concept of overmatch, the ability to outrange, outpenetrate, and outhit adversaries automatically, so that single rounds delivered with intent would achieve decisive results, even through modern ballistic protection. Pentagon leaders recognized that incremental improvements to 5.56's bullet design or case dimensions could never close the gap. What was needed was a step change, a cartridge operating at dramatically higher pressures, propelling heavier projectiles at velocities unmatched by existing intermediate rounds, yet still manageable in a shoulder-fired weapon. That realization set the drop everything and redesign wheels in motion. The decision to abandon a legacy caliber and embrace a brand new cartridge was a watershed, signaling a fundamental shift in small arms philosophy, performance above all, with precision and terminal effect as the highest priorities. The result of that bold choice is the 6.8 by 51 mm Common Cartridge, an ammunition system crafted from first principles to deliver overmatch in every trigger pull. You might hear 6.8 by 51 mm, and think of hunting cartridges like .270 Winchester, but this round is nothing like those throwbacks. It operates at an incredible 80,000 pounds per square inch, about 1/3 higher than most high-zero cartridges, thanks to a proprietary hybrid steel base and brass body case. That steel headlock prevents case rupture under punishing chamber pressures, while the brass body ensures reliable extraction and reloading. With that foundation, engineers propel a 140-grain bullet at roughly 3,000 feet per second, generating nearly 2,800 foot-pounds of muzzle energy, more than double the energy of standard 62-grain M855 5.56 by 45. Such raw power demands a bullet design optimized for drag reduction, a sleek profile with a high ballistic coefficient that slices through the air with minimal deceleration, preserving supersonic flight well past 1,000 meters. Translating those figures into battlefield advantage requires matching the cartridge with weapons and optics engineered for its unique demands. Chamber pressures and gas port timing must be precisely tuned to handle 80,000 psi. Bolts, barrels, and heat treatment processes all receive upgrades to endure the punishing environment. Optically, the XM250 fire control system becomes indispensable. This isn't simply a magnified reticle, it's a mini computer strapped to your rail. It lasers target distance, calculates bullet drop, adjusts for wind, humidity, and barrel temperature, and projects a dynamic aiming point. The synergy of match-grade ammunition, purpose-built firearms, and digital optics transforms every shot into a data-driven engagement. This holistic systems approach, ammo, weapon, and fire control, marks a sharp departure from treating ammunition as a modular commodity. Each element is co-engineered to amplify the round's performance. Soldiers learn new firing protocols, from precise ranging techniques to environmental data integration. They no longer take aim at a dot on a target, but interact with a guided engagement platform. In effect, the 6.8 by 51 mm Common Cartridge isn't just a bullet, but the keystone of a next-generation combat system designed to dominate peer and near-peer battlefields. To grasp the scale of this leap, compare 6.8 times 51 mm directly with its forebears. The 5.56 by 45 NATO round fires a 62-grain bullet at about 3,000 feet per second, yielding roughly 1,080 foot-pounds of energy and recoil of around 6 foot-pounds. Soldiers can carry hundreds of these rounds with minimal fatigue, but the energy curve falls off sharply beyond 300 meters, and its light projectile struggles against armor. The venerable 7.62 by 51 NATO, firing a 147-grain round at approximately 2,800 feet per second, offers 2,480 foot-pounds at the muzzle, but delivers punishing recoil of 17 foot-pounds, and each round weighs about 25 grams, limiting how much troops can carry. It retains power past 800 meters, but sacrifices rapid follow-up shots and increases muzzle flash and signature. Now consider the 6.8 by 51 millimeters, roughly 25 grams per round, on par with 7.62 by 51, but kicking only slightly harder at 19 foot-pounds, a manageable increase for trained infantry. Its muzzle energy approaches 2,800 foot-pounds, and it retains supersonic velocity beyond 1,000 meters. At 600 meters, where 5.56 rounds are subsonic and ineffective, and 7.62 recoils force a pause between shots, 6.8 by 51 cuts through advanced armor plates and allows rapid follow-ups. Ballistically, it delivers the flat trajectory once reserved for specialized long-range cartridges, yet in a standard infantry carbine or belt-fed support weapon. This perfect balance of weight, recoil, and terminal performance shifts how squads fight. Magazine capacities go from 35.56 rounds to 25.6.8 rounds, but each pull of the trigger counts more. Combat loads remain within ergonomic limits, so soldiers don't sacrifice endurance. The tactical envelope expands. Engagements formerly in the realm of designated marksman teams become standard-issue infantry capability. With 6.8 times 51, every soldier becomes a precision shooter at range, flipping the script on how infantry platoons plan, maneuver, and engage. Imagine you're a squad leader on patrol, scanning the tree line half a kilometer away. With 5.56, your best option was suppressive fire, spraying rounds to force movement or cover. Success hinged on volume, not precision. Now picture dialing your optic to 600 meters, acquiring your target, seeing the ballistic reticle adjust in real time for wind and elevation, and sending a single round that slices through enemy armor and ends the threat instantly. That's the reality the 6.8 by 51 millimeters brings. You shift from hoping your bullets work to knowing they will. This mind shift from quantity to quality changes every aspect of small unit tactics. Patrols can engage standoff targets with accuracy, reducing the need for close-in maneuver under fire. Ambushes become riskier for adversaries. Their movement corridors shrink when every vantage point becomes lethal. Support elements like medics and engineers find increased standoff safety. Psychological impact also plays a role. Hearing that distinct crunch of armor penetration carries weight on both sides of the line. Reflecting this, squad-level doctrines now emphasize deliberate, measured engagements. Each trigger pull carries strategic value, from target prioritization to ammunition conservation. Integrated suppressors further amplify these gains. By reducing muzzle flash and sound signature, they preserve concealment, allowing successive shots without immediately betraying position. Squads maintain communication under fire, coordinate movements, and exploit the element of surprise. Allied forces adopting this system report faster decision cycles, fewer close-quarters engagements, and a marked uptick in successful standoff engagements without casualties. In effect, infantry squads equipped with 6.8 by 51 millimeter firepower behave more like tailored sniper teams, yet retain the volume and flexibility of standard-issue rifle platoons. As shooters adapt, they also discover new techniques, shooting on the move at extended ranges, engaging multiple targets with rapid follow-ups, and pairing direct fire with drone spotters feeding targeting data back to XM157 optics. This networks individual shooters into an integrated, sensor-driven fire grid. The tactical impact on the ground is not incremental, it's transformational, rewiring how infantry fights, maneuvers, and dominates modern battlefields. Harnessing the 6.8 by 51 mm demanded new weapons platforms engineered around its extreme pressures and ballistics. The XM7 rifle replaces the venerable M4, featuring a short-stroke gas piston to handle 80,000 psi without fouling or overheating. Its receiver and bolt carrier group use advanced metallurgy and coatings, and every barrel undergoes cryogenic stress relief to endure the thermal shock of rapid fire. It comes factory suppressed, reducing sound and flash, and retains AR-style ergonomics for intuitive soldier transition. Alongside it, the XM250 automatic rifle replaces the M249 SAW. Lightweight belt-fed design, integrated recoil mitigation, and quick-change barrels combine to deliver sustained precision support fire at 600 meters and beyond. Central to both weapons is the XM157 fire control system. More than just an optic, it's a digital engagement suite. A laser rangefinder tags targets, while onboard sensors measure wind speed, ambient temperature, barometric pressure, and even barrel heat. The ballistic computer instantly calculates the firing solution and overlays an aiming reticle in your line of sight. Combined with programmable ammunition profiles, this system allows near-instant, accurate holds at extreme distances, even for shooters operating under stress. These technological leaps require new training doctrines. Traditional ranges capped at 100 to 300 yards have given way to extended live-fire courses at 1,200 and even 1,800 meters. Marksmanship schools now teach a digital workflow. Scan the environment, laser the target, verify ballistic solution, and execute the shot. Stress inoculation drills incorporate combat simulators that feed synthetic sensor data into the XM157, forcing students to adapt to electronic warfare countermeasures. Ammunition accountability becomes a critical skill. Every round is expensive, and commanders track expenditure with the same rigor as artillery rounds. In short, soldiers no longer simply carry rifles, they operate integrated combat systems. The line between infantryman and data specialist blurs as trigger pulls become part of a broader sensor-to-shooter network. This fusion of ammunition, weapon, optics, and training doctrine represents the most comprehensive small arms modernization in a generation, and it all centers on the revolutionary performance of the 6.8 by 51 mm Common Cartridge. Every time the military adopts a groundbreaking caliber, civilian shooters follow closely behind, and the 277 SIG Fury is no exception. Hunters chasing elk or moose at extended ranges find its flat trajectory and devastating terminal performance irresistible. Long-range competitors exploit its high ballistic coefficient to push past 1,000 yards with confidence. Precision rifle clinics offer dedicated Fury classes alongside 308 Winchester and 6.5 Creedmoor. Yet cost remains a barrier. The hybrid steel case construction drives premium pricing, and rifle availability is still limited to a handful of chassis systems and boutique bolt guns. Reloading requires specialized dies and meticulous handling of the steel head to prevent tool wear and ensure case integrity. Amid this excitement, the internet bubbles with half-baked takes. Some insist smaller caliber means weaker round, forgetting that the Fury's .277-inch diameter surpasses 5.56's .224 and carries more energy than 7.62 by 51. Others claim it's recycled WO2 tech, yet the cartridge's hybrid metallurgy and 80,000 psi operating pressure are firmly 21st century. A common refrain is that it's a solution in search of a problem. Conversely, real-world combat feedback drives its development. And yes, each round weighs more, but you need far fewer shots when every bullet delivers near one-shot stop performance. The reality is that the Fury fills a capability gap the civilian world only now appreciates, marrying Overmatch principles with precision rifle ballistics. As production scales with military contracts, we'll see more rifles, factory loads, and perhaps a drop in cost over time. If hybrid case technology proves durable, we could witness a revolution in how classic calibers, from .308 to .243, are pressure uprated, blending steel and brass to unlock new performance windows. In civilian hands, the 277 SIG Fury stands as a preview of tomorrow's ammunition landscape, where data-driven, high-pressure cartridges push the boundaries of accuracy and terminal effect. The U.S. Army blazed the trail, but every branch of the U.S. military and allied forces are watching closely. NATO logistics have long relied on 5.56 by 45 for ease of magazine compatibility, shared supply chains, and unified training. Introducing a hybrid case, high-pressure round means new manufacturing processes, different magazine designs, and potentially separate resupply lines. Allies will need to decide, cling to legacy calibers for simplicity, or embark on their own Overmatch journey. Early indicators suggest interest from partner nations in co-development or licensing, but full standardization across NATO remains years away. Meanwhile, hybrid case technology holds promise far beyond 6.8 by 51 millimeters. Imagine A308 Winchester operating at 70,000 psi, delivering 3,500 foot-pounds of energy, or A243, charting near laser-flat trajectories to 1,200 meters. If the steel-brass marriage proves reliable and cost-effective at scale, we could see an entire generation of reimagined cartridges pushing performance envelopes across hunting, competition, and military domains. Civil-military feedback loops will accelerate innovation as the Defense Department refines load profiles, recoil mitigation, and heat management. Civilian manufacturers will adopt lessons learned, driving nationwide improvements in brass quality, barrel metallurgy, and fire control electronics. The result, a virtuous cycle of performance gains and price reductions. What began as a battlefield necessity could reshape the civilian shooting world for decades. The 6.8 by 51 millimeter Common Cartridge is not merely another caliber, it's the centerpiece of a holistic small arms revolution. From purpose-built rifles and belt-fed support weapons to digital fire control systems and revamped training, every element aligns to deliver Overmatch, outranging, out-penetrating, and out-hitting any adversary with decisive, one-shot stop performance. For civilians, it offers a glimpse into tomorrow's ammunition technologies, high-pressure hybrid cases, ballistic computer optics, and precision rifle capabilities in every carbine. Now I want to hear from you. If you had the choice, would you build your next rifle around the 277 SIG Fury, or stick with proven cartridges like .3, 08, and 6.5 Creedmoor? Drop your thoughts in the comments. Hit that like button if this deep dive reshaped your thinking, and subscribe for more real-world analysis of the cutting edge in firearms technology. The future of small arms is here. Make sure you're part of it. Thanks for watching. I'll see you in the next video.